Hello everyone, myself Srivardhan Bhaviskar and this is SSJB's Mentora. In previous lecture, we have seen the various types of systems. Now let's continue the further discussion on the convolution. At the end of that lecture, we have seen that output of LTI system is convolution. So how it looks like, let's see here. Suppose I am having this kind of box. Let's consider it as any specific system. This is system. And this system is having one input signal. The system is having one input signal, let's say x of n, and one impulse response, h of n. Okay. And this will be having some output, y of n. Now, what is the convolution? Convolution is the output of a system, specific system, and this system will be LTI system, linear time invariant. We have already seen in the previous lecture what is the linear, non-linear, what is the time variant and invariant. So the system consisting of the linear, which is linear also and time invariant also. This is the LTI system to which the input signal is given. This is the input and this is the impulse response. This is the impulse response and y of n is the output. This is the convolution. Y of n will be equals to x of n convolved with h of n. Okay, I hope it's visible. The y of n will be equal to x of n convolved with h of n. So let's see the what is the formula of convolution, because y of n we need to calculate it mathematically. So there are basically two formulas. One is the continuous time domain formula. Y of t is equals to integral minus infinity to infinity x of tau h of t minus tau d tau tau tau. Okay, so this is the convolutional integral. This is the convolutional integral. This is the convolutional integral, and this is mostly for the most, not the mostly, this is for the continuous time domain. This is for the continuous time domain. Consider as spelling is not important. Concept is important. Okay. So this is the formula for convolutional integral where the sequence is what we can say continuous in time domain. Okay. So this is the formula for the continuous time domain. But mostly we do not consider the continuous signals because the integration might be get difficult and most of the university exams also don't ask this kind of questions. But if we are having any kind of such question, we will definitely see it. But the most important is the in the discrete time domain, the formula of discrete time domain. That formula is y of n is equals to summation k is equals to minus infinity to infinity x of k, h of n minus k. Okay, this is the formula which is too much important for all types of exams, including GATE examination and all. Because convolution is very basic concept, we need to understand it thoroughly. So this is the formula for convolution. Most of the times we just say convolution is multiplication in time domain or in frequency domain or whatever. The convolution is multiplication, but x of n convolved, not exactly multiplication. For that convolution, the output will be look like this. This is the formula for that. So this is the formula in discrete time domain for discrete time domain. This is in the discrete time domain. Let's analyze this formula further because this is very important formula. There are various operations involved in this formula. If we see carefully, and if I ask, let's say the first part is the x of k, sorry, h of k. h of k. This is the first part is given the original impulse response or the original signal. Formula of convolution, we place x of k and h of n minus k. How it's formed? Let's see. Initially, it was, let's say, x of k. Instead of n, we have just put the k, some another variable, because it's ranging from k minus infinity to infinity. It will also change according to the example. Firstly, it was x of k, then it becomes x of minus k. Okay, this is the complete hierarchy. This is the original signal. Okay, then this is x of minus k, and we can directly say what is the x of minus k. It's a time reversal or a time shifting, sorry, time reversal or time folding, we can say time reversal. Okay, then next comes x h of minus k plus n. Okay, this is x of h of n minus k, and this is h of n minus k only. Just reverse the order. H of n minus k plus n, and what is it? This is the time shifting. Time shifting. And which kind of shifting is this? H of minus k plus n. So this will be right shift. Right shift. Okay. Next, h of minus k plus n. When it is multiplied, here multiplication is there. It is multiplied with x of k. So multiplication operation is involved. Multiplication operation is involved. And next, I'll write here, next is the summation. Okay, summation of what? X of k multiplied with h of n minus k. So this is the addition finally. Okay, this part will no one will ask you, but this is for the information. We can also revise various concepts, because initially it was h of k, then it becomes h of minus k, time folding is done, then h of minus k plus n, right shift, time shifting operation is performed, then multiplication and addition. These many types of operations are involved in this formula. Let's discuss with one example how do we really mathematically find the convolution of any sequence. Let's take one very simple example. Okay, x of n. Now I will be having two sequences. X of n is equals to 4, 1, 2, 3, and h of n is equals to, let's say, 1, 2, and 3. Okay, so these sequences I am having x of n is equals to 4, 1, 2, 3, h of n is equals to 1, 2, 3. Output of this y of n, output of this is the convolution. And how do we write it? X of n convolved. This is the sign for convolution, the asterisk star. X of n convolved with h of n. And we know the formula of y of n, as it's a discrete sequences, it is summation from k is equals to minus infinity to infinity x of k h of n minus k. Okay, x of k h of n minus k. This is important formula. We should learn it, because it's having various kinds of, what we can say, various types of k is involved there, n minus k is involved there. What is the range of k? What is the start of y of n? We will see with this example only. Okay, so this is the formula. We will just keep it aside. Okay, so this is the formula. Now we need to discuss that what will be the various parameters involved here, because x of n and h of n, if any specific word is not mentioned in the example, like most of the university exams will tell that in the question paper they will mention that both the sequence start from the zeroth index. Okay, if it is not mentioned, another technique is the with the arrow. They can give an arrow, and with the position of arrow we can say which is the zeroth index or which is the different index. Mostly the arrow given position means if this arrow is pointing to 4, this will be the zeroth index. This will be zeroth index. And for this sequence, if arrow is pointing to 2, then this will be zeroth index. Then this is minus 1, this is 1. And if it is pointing to 4, then it will be right side only, 0, 1, 2, 3. This kind of technique will be there. Okay, arrow is given to 4 here and it is given to 2 here. And if the arrows are not given and no statement is mentioned, we will directly consider the first element as the zeroth index. But if the arrow is given, then that element will be considered as the element at zeroth index. Okay. So next part to discuss is y of s, from where the convolutional sequence will start. Ultimately, output will be also a sequence, but it is the convolution of x of n and the h of n. Now y of s is equals to summation of x of s plus h of s. Summation of x of s plus h of x. So this is also one important formula, that from where we want to start the sequence. Now here we will see y of s equals to x of s. X of s means from where the x of n is starting. It's obviously starting at the zeroth index. So y of s is equals to 0 plus. And from where the h is starting, h of s is what? The sequence is starting from minus 1, because arrow position is at the second index, second element. So the sequence will start from minus 1. So 0 plus minus 1, it will give minus 1. So our convolution sequence will start from the minus 1 position. So this will be minus 1. Third part comes the what is the length of the convolution, y of L. I will write directly here. Y of L. This formula is x of L plus h of L minus 1. Okay. So summation of the length of x plus length of h minus 1. And in this case, y of L will be equals to length of x is 4 plus length of h is 3 minus 1. So this will be 6. So length of this sequence will be 6. Means starting from minus 1, we will continue till minus 1, 0, 1, 2, 3, and 4. Okay, this means a part will be involved in this convolution. Okay, so these are the main part, the y of n, the formula where we want to start the convolution sequence y of s, and what will be its length. Also one more part we are missing, the range of k. What will be the range of k? K will depend on x of n, the given input signal. If it is going from 0 to 3, then it will be same only, 0 to 3. Okay, we can write it as same as of the x of n sequence. Okay, k की जो range होगी वो same as of x of n. Okay, so we have decoded the each and every part of the convolution formula. This is the convolution formula. We need to remember it thoroughly, because y of n is equals to summation k from minus infinity to infinity x of k h of n minus k. Okay, so we have analyzed the complete example, but this is only the initial part. Now next part comes is the mathematical calculation. How do we exactly calculate it? Okay, so let's see. We will write example one more time. It's the x of n is equals to 4, 1, 2, 3. X of n is equals to 4, 1, 2, 3, and h of n is equals to 1, 2, 3. H of n is equals to 1, 2, 3. This sequence is starting from here. This sequence is starting from here. Okay. Now we'll directly start from the mathematical calculation. Y of, now just be with me. We will solve the complete example. Y of n is equals to summation k. We have discussed that what is the range of k? K is from 0 to 3. 0 to 3 x of k h of n minus k. And what is the range of y? It is starting from minus 1. Okay. So the first sequence we will discuss is the y of minus 1. Okay. So the first part, the convolution, the first element we will be calculating here. Y of minus 1 is equals to summation 0 to 3 x of k into h of, now see, n minus k, but n is what? Minus 1. So here we will write minus 1 minus k. Okay. So we will just expand it. Summation sign is there. X of 0, h of minus 1. Just put x of, instead of k, we have put the 0 plus x of 1, h of minus 1 minus 1. Now, here we can say that if x of 0 is given, this sequence is starting from 0th index. I will write the indices also, it will be helpful. 0, 1, 2, 3. This is minus 1, 0, 1. Okay. X of 0 into h of minus 1. X of 0 is 4. H of minus 1 is 1. Okay. So 4 into 1. Plus x of 1 is what? X of 1 is 1 into h of minus 2 will be here. H of minus 2 is not present, so 0. Here we can also say that if this further sequence continues, okay, we will just, for the first example, we will discuss it thoroughly. Okay, we will write all the components. Okay, so 0 is 1, 1 is done. Now x of 2, as we are going to 3 only, x of 2 h of, now this is minus 1 minus 1 minus 2 was there. Now minus 1 minus 2 will be there, it will be minus 3 plus x of 3 h of minus 4 will be here. Okay, but if you see it carefully that minus 2, minus 3 and minus 4, these indices are not present in h of n, only it is up to minus 1. So this will become 0, this will become 0, also this will become 0. So ultimately our first element will be x of 0, which is 4, into h of minus 1 is 1. So our first element will be 4. This is the first part. Now quickly we will be solving all the other parts. Now jumping to the y of 0. Y of 0 will be what? Summation from 0 to 3 x of k h of, now what is the n? N is 0, so it will be minus k only. I hope it's visible, but just be with me. Now x of 0 into h of 0, because k is 0, both will be at the 0th index, plus x of 1 h of minus 1. Till now it's okay. Plus x of 2 h of minus 2 plus x of 3 h of minus 3. Here we can again decode that minus 3, h of minus 3 is not present, it will be 0. H of minus 2 is not present, it will be 0. So the final answer will be what? H of 0 into x of 0 into h of 0. X of 0 is 4 into h of 0 is 2 plus x of 1 is 1 into h of minus 1. H of minus 1 is 1. So 8 plus 1, it will be 9. Okay, so this is 4, this is 9. Now again we will go to the y of 1. Third part I will write here, and another part we will write in the next slide. Okay, so y of 1 will be what? We will write summation 0 to 3 x of k h of 1 minus k. Okay, this is the partition I will make. Okay, so summation from 0 to 3. No, I will write it directly. No need to write each and every term with clear. I hope you can understand. Now x of 0 h of 1 plus x of 1 h of 0 plus x of 2 h of minus 1, and the last x of 3 h of minus 2. Okay, so again we can decode that the last term will not exist because minus 2 is not present, but all other three terms exist. So we will write the summation of that. Now x of 0 is what? X of 0 is 4 into h of 1 is 3 plus x of 1 is 1, then h of 0 is 2 plus x of 2. X of 2 is 2 into h of minus 1 is 1. So this is 12 plus 2 plus 2. This is 16. So this will be the third part. Now let's minimize this only because we will continue to this slide. I hope it's kind of visible. If not, you can take the screenshot by uh, seeing the previous part of the video. Okay, now the y of minus 1 is done, 0 is done, now 1. Now let's say y of 2 is here. It will be summation 0 to 3 x of k h of 2 minus k. Okay, now x of 0 h of. Now you can see the h is for the minus 1 to 1 only. So 2 will also not exist. But here we will write. This is the first example. It will be too lengthy, but just be with me. We will be discussing shortcut after this. So x of 1, h of 1 plus x of 2, h of 0 plus x of 3, h of minus 1. So by decoding, this will gone because 2 is not existing, and another part exists, so we will calculate it. What it will be? X of 1. What is the x of 1? Is 1 into h of 1 is 3 plus what is the x of 2? X of 2 is 2, and what is the h of 0 is 2 plus what is the x of 3? X of 3 is 3 and h of minus 1 is 1. So 3 plus 4 plus 3. It will be 10. Okay. And this is the fourth part. Now we will again check what is the exact length. Length will be of 6. Till now we have calculated minus 1, 0, 1 and 2. In the next slide we will calculate the fifth and sixth. Okay. So what it was? Y of 2 we have calculated. Now y of 3. It will be summation from 0 to 3 x of k h of n minus k. N is 3 minus k. So it will be equals to x of 0, h of 3 will not exist, plus x of 1, h of 2, it will also not exist, x of 2, h of 1 plus x of 3, h of what is it? 0. So by decoding, it will be 0, this will be 0. Now we'll just calculate the two terms. And what are those? Now x of 2 is what? X of 2 is 2. Okay, x of 2 is 2. Then h of 1 is 3. H of 1 is 3 plus x of 3 is what? X of 3 is 3. X of 3 is 3. And what is h of 0? And h of 0 is 2. Okay, so it will be 6 plus 6, it will be 12. Okay, So I hope this is the second last, and the last one is the y of 4 is equals to summation 0 to 3 x of k h of 4 minus k. Now with the logic we can directly say that 4 minus if we k is 0, 4 will not exist, then 3 minus 0, 3 will not exist, 2 will also not exist. But for writing we will just write, but with logic, as soon as the logic will be developed, we can directly write it. But as this is the first time, we will write it completely. So this will be h of 4 plus x of 1 will be h of 3 plus x of 2. This is will be h of 2 plus x of 3. This will be h of 1. By decoding it, this will be 0, this will be 0, this will be 0. Only one term to calculate, and this is x of 3 is 3, I guess, and h of 1 is what? H of 1 is also 3. H of 1 is also 3. So this will be 9. Oof. So 6 terms. What are those? 4, 9, 16, 10, and 12 and 9. Okay, so I will this minimize it. So the sequence we got, the y of n is equals to, let's see it again. This, okay, minus 1. 4, 9, 16, 10, 4, 9, 16, 10, and 12 and 9. 12 and 9. And sequence is started from minus 1, so arrow will be here. So this is minus 1, 0, 1, 2, 3, 4. Total 6 number we got with the convolution. So this is the final output. Okay, this is the y of n. This is the convolution. Convolution. Also we can say the output of LTI system. So it was too lengthy, the video might also get lengthy, but this is the final answer. And in the next video we will see what is the exact shortcut of the convolution with the matrix method.